Hello, everybody. I will start my today another live coding session. So today I will solve this question, 3-sum. So in this question, I'm given an integer array nums, and I will return all the triplet which means that I, J, I, K, J, K. So 3 indexes are unique. All of them have unique indexes, and some of them should be 0. Notice that the solution set must not contain duplicated triplet. Yeah, this is not duplicated triplet. Okay. So in this question, the input should be integer array, and I will return the list of triplet. Triplet is a kind of tuple which has 3 elements. Yeah. So I will return the triplet of not the indexes, but the values. Good. Okay, so I will think of this question with an example. So let's say, oh, by the way, I will just confirm something. So my concern, or I should say question number 1 is all of them are positive or negative or 0 or positive. So that's what I'd like to confirm first. And aside from that, yep, nums can be empty or not, or I should say, in the case there are less than 3 elements. Yeah, I'm wondering if this is possible. But even if it is possible, I just have to return an empty array. So actually, it doesn't matter that much. But I just want to confirm. Okay, and the answer is that for the first one, from the constraint, I can say this is yes. It should be negative or 0 or positive. Good. And for ranks of nums, yep, this is, I can say, from the first constraint, I can say length of nums is 3 or larger. Good. Okay, so I just wanted to confirm constraint. Good. I will think of some examples. Okay, so for example, in this case, I will try to check, for example, if the first element is this one, 1. So in this case, the remaining, sum should be -1. My task is to find -1 pair inside of this range, the remaining range. And yep, I can find it because obviously -1, 0 are, they make the sum 0, -1. So I find this one. Good. Aside from that, I don't find -1 sum. So that's it. And I will choose 2. And when I choose 2, I'd say I don't include element before this. Because if I can include that, something which is before this 2, it should be found already. For example, if I include 1, then it should be found. That tuple should have been found when I think of the element 1. So I will try to create the sum -2 in this range. Yep. And yes, I find it 0, -2. Good. And when I start from here, I try to create 1 here in this range, and I can't find it. And if I start from here, obviously I can't, because I can't find 2 elements from the remaining only single element. So no, I can't find it. So I will return this and this. Good. Okay. So I can say this was the brute force approach. Yep. So for each first number, find the pair whose sum is negative num. So for the time complexity, for the line 81 loop, it should be n elements. And after that, I will try to find the sum whose, find a pair whose sum is equal to negative num. And definitely I can use the two-sum approach here. So what I mean by two-sum is that, yeah, very famous one, you know. So I keep the seeing element in the hash map, and while traversing, for example, if I'm at say 0, the complement should be, in this case, -1. I will check. I've already seen -1 so far, and I will keep them in the set, so I can find it in the constant time. I can find the pair in the constant time for each step in the traversal. So with this takes n steps at worst, and this takes n minus 1 steps in the worst case. So the time complexity should be O of n squared. And for space complexity, it should be O of n, because I have to keep track of the set, the number set, which should store up to n minus 1 elements. Because if I, move the first num, I can start from the empty set. So yeah, it doesn't grow more than n element. Okay. So I said this is the brute force approach, but this is, I think, yeah, efficient enough maybe. Yeah. Okay. And I will think a little bit if I can optimize this more. So if I try to optimize this better than this, I think sorting and log n time is cost-free. So I will try it. So when I sort it, it becomes like this. -1, -2, -1, 0, 1, 2. Yep. So with this, I will try the, move the first num again. And what I would do is try to create the sum 2 here. Oh, I forgot 0. So probably I can use the 2 pointers, which going from left and from right. Yeah. And I think in this way, yeah, time complexity is still the same, O of n squared, but space complexity should be, oh, again, this is O of n, because sorting takes O of n extra space. In case of Python, it is the temp sort, which caused linear space complexity. Actually, sorting takes at least n log n time complexity and O of n space already. Yeah. Okay. So what should I do? I choose the left and right pointer and keep moving them maybe? Or mm, if I choose -2, I want the sum 2. Yeah. Okay, so if I choose -2 first, I try to find sum 2 here. And if I start from -1, I try to find sum 1 here. If I start from 0, I try to create 0 here. And I'm wondering if I can find it quick way. Ah, well, what I found is the solution set must not contain duplicate triplet, which doesn't mean there are not unique duplicate element in the given nums. But there could be duplicate element like 0000, but I just have to return 000 only once. And yeah, order in the triplet doesn't matter. Okay. Hmm. So I choose -1 and -2 and -1. Since the remaining is 3, I can find it in log n time, but still it takes n squared log n. Yeah. Hmm. So I sort it first. Then what can I do? Say if I choose the center number first, like this, I want the sum whose sum is 0 now. So wait, can I use the 2 pointers now? Let me try it. So let's make it a bit complicated. Let's say I choose 0. In that case, what I'm trying to find is the sum two numbers whose sum is 0 from this one and from this one. Yeah. So I can keep track of the set of these numbers. Let's say I have it. Hmm. But still, if I have the numbers, I have to, it takes orb and squared. Mm, yeah. Okay, so I don't come up with the n-log solution. So let me implement the n squared n space orb n solution. Yep. So this is the first index. And what we do is, so here's sum minus 0 minus nums, like this. So I move the pointer. If the complement is inside of the scene set, now I can say nums I and pair sum minus num. So this is the triplet. But I have to deduplicate the deduplicate the triplet. So I would say return should be set. And I will sort it. And append it to read. Yep. Sorry, let me do that here. It doesn't matter at all. But like this. The triplet should be list, so I sort it. Then I make it a set. No. I make it a tuple and append it to read. Then, because I have to return the list. Oh, no, wait. So after that, I will add this current number to the scene set. Yes. Then in the end, I return read, but I will make it to list just in case. Okay. Yep. So in this way, I'm pretty sure there aren't duplicated triplet because it's sorted and stored in the set. So duplicate elements shouldn't exist because the thing is the read is the set. Okay. Oh no. And one thing I forgot, there's something wrong is obviously even if the pair sum is not found, I have to append this nums I to the scene set. Okay, I will quickly walk through my code. So n is now, oh, by the way, So I expect the list to include this one, even if each tuple or tuples are not sorted. Okay. So NA3 returned is now empty set. And here I1 begins with 0, then 1 until 2. So I start with 0. Oh, the pair sum is now 0 minus nums I1, which is 0. So this should be now 0. Yeah, so pair sum is 0. And I initiate the scene set. And here I move from index 1 to 2. If I is 1, nums 1 is 1. So pair sum minus 1 is negative 1. So this is not true. So I go to line 58 and I append this nums I, which is 1, to the scene set. So now it becomes 1. Yeah. And I keep going. So now index is 2. So nums I is number 2. And pair sum should be 0 minus 2 is negative 2. Sorry, 0 minus 1 is negative 1. So 0 minus negative 1 is 1. And 1 is in the set, yes. So I go to line 56, and now I get nums I1 is now index 0. This should be 0. And nums I is now index 2. It should be negative 1. And now pair sum minus nums I. And because pair sum is 0 minus negative 1 is 1, 1 is here. And I sort it, negative 1, 0, 0, 1, and make it tuple and add it to the read. Good. Okay, and I will add this nums I, which is now 1 to the scene set. So scene set has now negative 1, so negative 1, 2. Okay, is that it? And I come back to line 54, and now index is 2. So when index is 2, no, sorry. I finished this, so I go back to line 50, and I start with index 1. So I don't continue with anymore, but what happens is that in line 54, I begins with index 2, which means that I can't really find any pair because I have only one index remaining. So there's no change on the read. Then when I come back to line 50 and index 1 is now 2. So what happens is that I start with negative 1. And what happens is in line 54, because I1 is 2, 2 plus 1 is 3. And n is 3, so it range 3, 3. So I don't have any I, which should be traversed. So I finish the loop and I go to line 60 and I will return the list of negative 1, 1, 0 tuple. Good, passed. Okay, so I covered those lines, and so I'm pretty confident in my code. I will submit. Oh yeah, read this. Good. Oh, time limit exceeded. Okay, so I have to optimize this to maybe enter again. Yeah, I will think. So as I said, sorting is code-free operations. I will do that. Mm. So mm, now let's come back. So as I said, sorting is free, cost-free operation. So I did it. And let's say I choose 0. I mean, I try to choose the center number first, but again, it takes n squared time because I have to iterate each, I mean, maybe index on the left-hand side. And then I can find the complement here. Maybe I can put them in the set and I can find it. But it still takes, n times n times 1 is n squared. So one thing I've noticed is that if I choose 3 elements, let's say I have 0. In that case, the remaining number should be 0, 0 or positive negative. And if I don't have 0, what happens is that I have to choose 2 negative numbers and 1 positive number. Or I have to choose 1 negative number and 2 positive numbers. So let's say I will make it into 3 groups. Negative groups and positive groups. And I will think of 2 cases. 2 sum. The 2 sum can be -3 and maybe -1, -2. Let's sort it. -2, -1. Tuple. Or maybe some other. And also I will think of 1 sum case. This is obviously just a set it enough. -1, -2, and -1. And I will do the same for positive numbers. For 2 sum, 3 can be 1 and 2. Maybe this should be the set. A list, I mean. Let's say I have 1, 4, and 2, 3, something like that. And for 1 sum, definitely I should have 1, 2, 3. Okay. So with that, let's say I have 1 positive number and 2 negative numbers. In that case, I have to traverse each element, and then I find the pair from here, then I get a triplet. Yeah. Or if I should have 2 sum, 2 positive numbers and 1 negative number, I traverse this 1 sum. Then for each, I will try to find the, sum 2, then I find it, and I find the triplet. So it should be appended to the, returned answer list. Yeah. Oh, wait. But it still takes n squared time when I try to calculate the 2 sum. It doesn't work. Oh, wait. When I take a look at this example, I find so many duplicated elements. Maybe I can deduplicate them because each element doesn't have to include more than 3 elements. So I mean, if I have 0 more than 4, more than 3, it doesn't work because I can choose up to 3 elements. Okay, so let me do that, optimization here. The definition here is remove elements which deduplicate elements so that unique false or later duplicated elements are removed. I will try to do this. Yeah, so this is it. So I keep track of the counter. So this is key is the number and value is the count, which are included in the returned array. And I traverse each number in the nums list. And if count is already 3, I will skip that number. Otherwise, I append it to the returned list and I increment the count. And I return the rate. Good. So I will try it again. Oh, accepted. Okay, good. So I will quickly wrap up. So today I solved the question 3 sum. In this question, I'm given an integer array nums, which each element can be positive, negative, or 0. And I will try to find all the triplet whose sum is equal to 0. And each element, I cannot choose the same index more than once. And I cannot include the duplicated triplets in the returned list. Yeah. And for this question, my approach was quite simple. For each first element, I use the two-sum approach for the remaining 2 elements. What I mean by two-sum approach is that I move the pointer and I keep track of the seen numbers in the set. And every time I traverse a new number, I will try to find if the complement is inside of the scene set. And if it is, I find the two pair. I find the pair whose sum is specific number. So in that approach, it took n squared time compressed t. And I did a small optimization firstly. So I deduplicated elements. And I made sure that the also later duplicate elements should be removed, which is skipped. and I create this nums array, and I did the approach I told on the deduplicated array nums. In that way, I could avoid the, I mean, it could work quite well. For example, if the element are 0, 0, 0, 0, 0, 0, yeah, because in that case, it is deduplicated into 0, 0, 0, so it takes much less time. The time complexity is still n squared, but in some cases, it works quite efficiently. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.